Hi, welcome to today's video looking at the AQA Topic Tests 1. It's a 20-minute test and it's for the basic algebra and it's for the higher tier. Okay, some of this may also be appropriate for the foundation tier, and as I go along, I will be explicit in what's foundation and what's higher tier. But this is aimed predominantly for the higher tier students for grade 4-5, okay, maths that we're looking at, and possibly grade 6 towards the end. Okay, we're going to start with question number 1. Circle the expression that is equivalent to 6n minus 3n times 2n plus n. Well, using BIDMAS to answer this question, okay, we're going to do the multiplication part first, okay, and then we're going to sort out the addition and subtraction afterwards, okay? So 3n times 2n gives me 6n squared. So now the sum becomes like this: 6n minus 6n squared plus n, okay? So the signs still stay the exact same. 3n times 2n, 3 times 2 is 6, and n times n is n squared, or n to the power of 2. Collecting like terms, okay, 6n and plus n becomes 7n. So your final answer is 7n minus 6n squared, or the other convention is also correct, minus 6n squared plus 7n. Either one means the same thing. So we're going to circle option number 3. Now, question 1 is more likely to appear on a higher tier question, although I have seen these appear towards the end of a foundation tier paper. So make sure that you are happy with BIDMAS or BODMAS, they might call it. Okay, so make sure that you learn the rules: brackets, indices, division, multiplication, addition, subtraction. So always follow that way, okay? Question number 2. Expand this single bracket, circle your answer. Well, a times a is a squared, and a times negative 4 is negative 4a. Okay, so a squared minus 4a or minus 4a plus a squared. Again, either convention is fine. Okay, this is question number 2. This is likely to appear on a foundation tier paper. It's very unlikely that this question will appear on a higher tier paper, unless it's at the start of a higher tier paper. Okay, this is question number 3. Factorize fully this expression, 10x squared minus 5xy. So the idea that we factorize means put it into brackets. Fully means take out all the common factors that have numbers and letters in. I've got an x squared and an x, so the highest common factor is x. The highest common factor of 10 and 5 is 5, okay? Because 5 is the biggest number that goes into both 10 and negative 5, okay? Or 10 and 5, sorry, without the minus sign, sorry. Okay, so 5 is the biggest number that goes into both 5 and 10 without giving a remainder. 5x times 2x gives 10x squared, and 5x times negative y gives negative 5xy. Okay, so the answer we get is 5x brackets 2x minus y. Okay, and this is likely to appear on both a foundation and a higher tier paper. I've seen these appear in lots of AQA papers and even EdXL papers this year, and some OCR papers as well. Okay, for both foundation and higher, this sort of question. Okay, so make sure that you are happy with factorizing single brackets, and also check out my other videos on factorizing quadratics, okay, or double brackets in this case. Sorry, in a different case, I mean. Question number 4. 3x brackets x plus 12 is equivalent, i.e. the same as 3x squared plus c squared x. Work out the possible values of c. Well, if I expand the bracket on the left hand side, I get 3x squared. 3x times x is 3x squared, and 3x times positive 12 is positive 36. That has to be the same as, i.e. equivalent. Okay, so this is what I call an identity, where the left hand side is true for the right hand side. Oh, there should be an x there. Plus c squared x. If I now compare coefficients of x squared, 3 equals 3, so that's correct. Compare coefficient of the x's, I've got 36 is equal to c squared. Okay, c squared is equal to 36. Taking the square root of both sides. Now in this case we're going to be careful. C is equal to plus or minus the square root of 36. And the reason for that is because a quadratic, a power of 2, will always have two distinct real solutions. Okay, so plus and minus that, which is plus and minus 6. So C can take the values of plus or minus 6. Okay, it is possible values. Okay, so the plural here, okay, makes it clear that we've got two distinct values. So make sure that we read the question carefully. Okay, this is question number 5. The rectangle and the equilateral triangle have equal perimeters. Okay, write an expression in terms of x for the length of the side of a triangle. Give your answer in its simplest form. Okay, so this one's going to be 3 brackets x plus 4x plus 2, and then the other side's going to be 6 brackets x minus 2 for the other side of the width. Okay, so now if I expand all the brackets and then I collect like terms, one quick way of doing it is if I do 2 lots of all these times together, or sorry, this times together, this added, sorry, this bracket multiplied actually, and this bracket multiplied actually, but then add my expressions together. Sorry, I'm struggling to get my words out today, guys. Hopefully, like, yeah, it makes sense what I've just said there. So expand these two out, collect like terms, and then just double my answer because it repeats twice. Remember that perimeter is the distance around the shape. Okay. Right, and then we're going to close that bracket there, and then we're going to close the big bracket. Okay. There's not really a bracket there, it looks like a line. Okay, let's just curve it a bit. Yep, that's alright. So expanding this, I get 12x plus 6 plus 6x minus 12. Collecting the like terms, I get 18x plus 4. So it's 2 lots of 18x plus 4, which is going to be 36x plus 8. Now, it's wanting it in its simplest form, so I am guessing here that we would just factorise, okay, because this part's been factorised here and kept in a bracket, so highest common factor is 4 brackets 9x plus 2, that will factorise into, because the highest common factor between 8 and 36 is 4, the highest number that goes into it is 4, and then x is not common in both, so 4 lots of 9x is 36x, and then 4 lots of 2 is 8. Okay, and that's my answer for that question. Now, this question is more likely to appear on a higher tier paper, although it could appear on the end of a foundation tier. Okay, so perimeter, remember, is distance around the shape. Okay, so it's the distance all around the shape. Okay, going this way, this way, this way, and then this way, all the way around, without actually cutting through like the lines. Okay, just going around the shape, okay, for that question. So make sure that you're happy with expanding single brackets, collecting like terms. Okay, so I collect all my x's together and all my numbers together once I've expanded it. Okay, so 12x plus 6x is 18x. 6 take away 2 is plus 4. And it's two lots of it because I'm adding on 3 brackets 4x plus 2 plus 6 lots of x minus 2. Okay. This is question number 6. Okay, I've got this expression here, okay, or this equation, sorry. 6 brackets x minus k equals 5k minus plus 4, where k is an integer, okay, positive integer. So that x must be an even number. So our answer needs to be x is equal to something like 2n, okay, where 2n is an even number. Okay, that's what we are working towards. Let's just change colour here so we're not getting ourselves confused. Expanding this bracket, I get 6x minus 6k is equal to 5x plus 4. I'm now going to bring all my x terms together and my non-x terms together to one side. So bring my x's to this side, bring my 6k to this side. Remember that the sign changes when I move it across the equal sign. 6x take away 5x is just x. And then I'm going to have 4 plus 6k or 6k plus 4. Either way is fine. Okay. Now, the last step here is I'm going to just take out a 2 as a factor, okay, out of this pot here. So I get 2 lots of 2 plus 3k. Okay, and then I'm going to close my bracket. Okay. Right. So the fact that I've got a bracket here and everything's being times by 2 means that whatever the value of k is, if I double it, it will always give me an even number by definition. And it's in this form, okay, where we can treat n, okay, as 2 plus 3k, you could say, or 3k plus 2. But the idea is by having that bracket there, it confirms my answer, okay, and it proves that it's even, okay, for all positive values of k, okay, so k has to be strictly greater than 0, okay, or even equal to 0, I suppose, okay, but it can't be negatives, okay, because if it's negatives, then we're going to have a problem, okay. This is question number 7, guys. The diagram shows 2 rectangles. All dimensions are in centimeters. Okay. Work out an expression in terms of x for the shaded area. Okay. So I'm gonna label this as number 1. Okay, and the big rectangle is number 2. So the area of the first rectangle, okay, is length times width. So it's 3 lots of x plus 1 when I expand that bracket. For the small area, expanding this, I get 3x plus 3. Okay, and expanding the bigger one, okay, I'm going to have x lots of, or 5x at the front, brackets 2x minus 1, okay. Now, I've stuck the x there, okay, because obviously I'm timesing it by x, so I'm timesing this by this, okay. So I can just put the x at the front there, because it's still going to be times by, okay. Expanding this, I'm going to get 10x squared, okay, subtract 5x, okay, 5x times 2x is 10x squared, and then 5x times negative 1 is negative 5x, okay, and similarly here, 3 times x is 3x, and 3 times positive 1 is positive 3. Okay, the area of the shaded region is going to be this, take away this, so we're going to have 10x squared, okay, minus 5x, subtract 3x is minus 8x, okay, and then we've got nothing, take away that positive 3 is going to be a minus 3 there, okay. give your answer in its simplest form. Well, this is the simplest form actually, okay, so I can't simplify this any further, but I might be able to factorize it. Okay, so let's try factorizing it into a double bracket. Okay, let's try 10x and x, or we'll try 5x and 2x, depending on which one it might be. Okay, this one's a bit easier because the factors of 3 are nice and easy. I've only got a few combinations to try before obviously it becomes a problem. So the factors of 3 are 1 and 3. Okay, so I'm trying to make 8x. Okay, so if I put a 1 here and then a 3 there, that will give me minus 7x, which is not all what we want. Okay, if I try and put a 1 here and a minus 3, that's not going to work. That's going to be 5x minus 6x, which is going to be plus x. Okay, so I don't believe that that can actually be factorized, guys. Okay, unless I'm actually mistaken. Okay, if I put a 3 here and a 1, then I'm going to get 13x, yes, so it's not what I want there, okay? And if I put a plus 1 here and take away 3, it will give me plus 7x, and even if I switch the signs, make it positive 3 and minus 1, then I still get a minus 7x, but we want minus 8, so I can't factorize that any further, okay? Question number 8. Write this in the form a brackets bx plus c, where a, b, and c are integers and a is bigger than 1. Expanding my single bracket, I get 21x, subtract 3, minus 6x, minus 24, plus 2. Okay, and it's a minus 24 because it's a negative times a positive. Okay, which gives me a negative sign, and minus 6 times x is minus 6x, okay, 3 times 7x is 21x, and 3 times negative 1 is negative 3. Collecting like terms, 21x minus 6x is going to be 15x, okay, minus 3 plus 2 is minus 1, minus 1 minus 24 is going to be minus 25, okay. Factorizing this, so taking out a common factor, okay, of a number, because it's in the form a brackets bx plus c, so it tells you straight away it's going to be 5 brackets 3x minus 5, okay. The highest common factor between 15 and 25 is 5, okay. It's the highest number that goes into both of these numbers without a remainder, okay. And a little clue there tells me that it's a number out here, and then it's bx plus c. So a is equal to 5, b equals 3, and c is equal to negative 5. Okay, and that concludes our answer and confirms our answer. Okay, because all the values are strictly greater than 1. Okay, for that question. Right, guys, so that is the end of today's video. So I hope you found it useful. I hope you found it informative. If you did, please press like, please subscribe to the channel if you're new, okay, and lastly, please click that bell icon so you don't miss out on further videos and further uploads, okay. But that's it for me today, guys. Thanks for watching. I'll see you for the next one. Bye for now.